Cyrus the frog sits on a flat surface. He jumps, landing 2 feet away. He then chooses a direction at random, and again jumps 2 feet away. What is the probability that after the second jump, Cyrus lands within 1 foot of his starting position? So this problem is actually not that bad at all for number 20, once you draw the configuration out. So let's draw a couple of points. I'm going to label Cyrus's starting position as point A. And then without loss of generality, let's say that his first jump takes him 2 feet to the right to point B. Now from point B, Cyrus can jump in any possible direction, chosen randomly and uniformly. We need to figure out which directions Cyrus can jump so that he's within 1 foot of his starting position. Now we see that Cyrus needs to jump in a direction that places him pretty close to A. In particular, Cyrus could jump to, say, this point C1, where C1 is, where AC1 is 1. Or Cyrus could jump to this point down here, C2, such that the distance between AC2 is 1. Or Cyrus can jump any direction between the segments BC1 and BC2. So out of all possible directions, Cyrus needs to jump in a direction so that the frog lands between C1 and C2. So the desired probability is equal to the probability that the measure of, so the probability that AC is less than 1. This is equal to the measure of angle C1B C2 divided by 2 pi. So in order to figure out this angle C1B C2, I'm going to drop an altitude from B onto AC1, since we can notice that ABC1 is isosceles. So let's drop an altitude from B onto AC1. Because it's isosceles, this altitude is going to bisect AC1. Therefore, if M is the midpoint of AC1, then MC1 is a half. So now we can use a little bit of trig just to express this angle in terms of sines. So we know that sine of angle MBC1, this is equal to 1/2 over 2, which is 1/4. So therefore, angle MBC1 is equal to the inverse sine of 1/4. Now we can notice that triangles ABC1 and ABC2 are in fact congruent. Therefore, we actually need 4 of these angles. So it follows that the measure of angle C1B C2, this is equal to 4 times the inverse sine of 1/4. And the desired probability is 4 times the inverse sine of 1/4 divided by 2 pi. And dividing top and bottom by 2, we get 2 sine inverse of 1/4 over pi. Therefore, the answer is E.